Now see isomers. Isomers, actually, this word has been derived from the two words iso. Iso means same, and mers. Mers means component, constituent, any same component. These are the compounds having same molecular formula but different structures. Okay, so this is the definition of isomers, and this phenomenon is called this phenomenon is called isomerism. Examples: we have a formula C4H10. C4H10, if you draw the structure, it can be drawn like this. Four carbon atoms, we have arranged all of them in a linear manner, and carbon has valency 4, so it should form 4 single covalent bonds with each other. And see, 4 carbon atoms and 10 hydrogen atoms are there. But it can be arranged in another way, that 3 carbon atoms in a chain, but one as a branch. So now satisfy its valency with hydrogen atoms. There should be 1 hydrogen atom. There should be 3 hydrogen atoms. So I'm drawing displayed formula for both of these. Both of them have the same molecular formula, C4H10. You can find it. 1, 2, 3, 4, and hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But they have different arrangements, so they have different names. The rule for naming the compound is find the parent chain. Parent chain is usually the continuous chain, not necessary that it is a straight chain, not necessary. And here there are 4 carbon atoms, so suffix but is used. There is no functional group, all the carbon-carbon bonds are single, so we use N, butane. But here, if you see the continuous chain, so continuous chain should be straight or it can be this. Both of these can be taken as basic chain or the parent chain. So in parent chain, there are 3 carbon atoms. This is the chain of 3 carbon atoms. But anything that is other than the chain is called group. Sometimes it is functional group, and here it is a just alkyl group. And this group contains 1 carbon atom. So 1 carbon, it is meth, and as a group, it is written as "-ile", methyl group. And in Pakistan and India, it is pronunciated as methyl. Actually, it is correct pronunciation is methyl. So this is the methyl group. So what is its position? We should mention its position from here: 1, 2, 3. It should have the least number. So either you numbering from here or from here, it has the same number too. So we will write 2-methyl and the basic chain has 3 carbon atoms, prop, and all the carbon-carbon bonds in the basic chain are single. So suffix N is used. So its name is 2-methyl propane. So you can understand that both of these are isomers because they have same molecular formula but different structures. And the molecular formula I'm writing here, this is C5H10, sorry, C5H12 and C. The first arrangement is same in a straight line, 1, 2, 3, 4, and 5. And now arrange the hydrogen atoms. So this is another important organic molecule. If you write its name, it is simple pent because 5 carbon atoms are there, and because all the bonds are all the carbon-carbon bonds are single. So it is pentane. But it can be arranged like this. Okay. Now, if you want to select a basic chain, the basic chain can be the straight chain or it can be turned here. Then this would be the group, no issue. So this is the group, and group here again it is the methyl group because 1 carbon atom is there. So the name, first we write the group. Numbering should start from here, 1, 2, 3, and 4. On second position methyl is there, so 2-methyl, and there are total 4 carbon atoms in basic chain. So we use the word bute. And why not 3? Because according to the rule, we should give the minimum possible number. If we count from here 1, 2, 3, so it is better to write from the nearest one.
Okay,
But
sir.
here one more structure is possible. 1, 2, 3, and 1 carbon atom here and 1 carbon atom here. And now satisfy valency of hydrogen for each carbon atom. So every carbon atom except the central one all have 3 hydrogen atoms. Now basic chain can be straight chain or can be vertical chain, or it can be like this turning. So the remaining are the groups. This is methyl group, and this is also methyl group. We can't uh, count collectively, okay? We take them separately. There at the position is 1, 2, 3. Both are on the same position. So we write 2 twice. 2 dimethyl.
Mhm.
The word di is used. And for the remaining part, it is propane. Propane. Got it? C3H7OH and C3. So 1, 2, 3. OH. So OH can be on any other any carbon atom. Okay. And remaining are hydrogen atoms. So arrange the hydrogen atoms over there. Okay, so now its name. First, the basic chain. Basic chain contains 3 carbon atoms, so it is prop. And because all the carbon-carbon bonds are single bonds, so it is prop N. We don't write E because the next part that we are going to write is all. Both have the vowel. So to avoid two consecutive vowel, we we use we omit the E from their ending of the N or in. So it is propane 1 all. So the name changes propane to all. It was the propane 1 all, it is propane 2 all. So these are also isomers of each other because they have the same molecular formula but different structures due to the position of OH group. C4H8, it is one of the alkene. It follows the general formula CnH2n. 4 carbon atoms are there. So as it is an alkene, so there must be a double bond either between 1 and 2 or 2 and 3. We can write anywhere. So the remaining valency of carbon will be satisfied by adding hydrogen. Show the bonds with hydrogen here. This is C4H8. C4 means this is but. There is a double bond and the position of double bond is between 1 and 2. So the position would be written as 1 butene. Okay, yeah, but 1 ene is the better pair. Another isomer of this butene is, you can draw it again. So there would be the double bond. So as the double bond is between 2 and 3, so the name would be but 2ene. So these are also isomers of each other. And one more thing is there. C4H9OH. It is an alcohol containing 4 carbon atoms. So if you will see 1, 2, 3, 4. So one of the structure is this, and you can place OH anywhere. First I'm writing OH here. It is on the first position, whether you write here, here, or here. There is no difference. So if you write its name, it should be 4 carbon atoms. So it should be butane, and position of OH is 1. So butane 1 all. And another isomer is here. So near to this terminal. So numbering would start from here. 1, 2, 3, 4. So the name of this compound would be butane 2 all because OH is on the second position. But there is another possibility of such an alcohol that has the same molecular formula C4H9OH. And you can see here. So here, this CH3 is also out of the basic chain. So this is a group. And fortunately, the position is same. So the name of this compound would be 2-methyl. 3 carbon atoms are there in basic chain. So prop N because all have the single carbon-carbon single bond. And on second position of this propane, OH is also present. So 2-ol. So its name is 2-methyl propan 2-ol. Okay. Now see one more thing. Here I have written two structure of C4H8. Now there is one more structure is possible. 1, 2, 3. And there is a double bond. If there is a double bond, so and it is at terminal, so two hydrogen atoms would be there. And here three hydrogen atoms are there. Now what should be the basic chain? Remember that basic chain must contain double bond. Okay, in our syllabus. So this is the basic chain. So this is carbon number 1, this is 2, and this is 3. So on carbon number 2, there is a methyl group. So name of this compound would be 2-methyl 2-methyl, 3 carbon atoms in basic chain, so prop and ene because there is a double bond. And no need to mention the position here. Here mentioning the position is necessary because it could be one but 1-ene or but 2-ene. But if 3 carbon atoms, then definitely wherever the double bond is present, we start the numbering from there. So it is always fun. If you want to write, you can 2-methyl prop 1-ene. It is also correct. I have no objection. But according to
Okay, sir.
IUPAC, yes, but according to IUPAC, it is not necessary. 2-methyl prop 1-ene. It is also correct.